Hello and welcome to Getting Technetical, a podcast brought to you by Technetics. I'm your host, Michelle Dawn Mooney. Today we're talking about decarbonization efforts and goals in the aerospace industry. I have a great guest for this conversation. Stefan Guignard is Director of Strategy at Technetics. Stefan, thank you so much for being with me today.
Thank you, Michelle. Good morning.
Looking forward to this conversation. Before we dive in, can I ask you to give us a brief bio if you can?
Yeah, sure. It would be a pleasure. So I'm Stefan. I'm with Technetics now for almost 18 years with different roles. I'm an engineer by degree, but I worked a lot in sales and the technical sides and different roles that allow me to gather some knowledge about different markets, including the aerospace that I would be very glad to speak about with you today.
And we are going to do a lot of speaking about aerospace today. So let's jump in because we have a lot to cover. Where do we begin? Well, let's start here. How has the aerospace industry evolved in recent years in terms of adopting decarbonization technologies?
That's a great question. So to get back in history, for the Paris Agreement in 2015, the aerospace industry started a journey to decarbonization. And back in 2018, if I remember well, there was a commitment from the major player, Airbus, Boeing, and so forth, to get to a certain level of decarbonization by 2050 with certain range by 2030. So this is a journey that is not new, but that is accelerating due to all the evolution about climate change and everything. Today, I think aerospace industry is coming to, there is debate about the numbers, but 4 to 5% about the emissions at the global scale. And that's a need. There is a need to decarbonize the aerospace industry. The evolution it's accelerating. There is new technology coming on board. There is a lot of challenges to be solved because the old technologies are not fulfilling the engagement that the industry took back in a few years ago.
So they're really exciting advancements that we are going to talk about during this conversation. What are some of the most promising technological advancements currently being developed to reduce carbon emissions in the aerospace sector?
That's a great question, and there is quite a few. The classical one that we have, it's like the weight reduction that was always a big subject for the aerospace industry, but it's even more prevalent. Before it was more to reduce costs, to reduce fuel consumption, which is reducing the emission at the end of the day. So still a big play that we can see for the structure, that we can see for different components. But weight reduction is definitely one. There is the fuel optimization. How to make fuel more sustainable and how to make fuel greener at the end of the day. The efficiency of the turbines is a big deal. Sometimes electrifications for any actuations and some things that we have to do on an aircraft, for instance. So there is different themes from weight reductions, the fuel optimizations, the efficiency optimization from the engine that were always around, but now it's like to get to the targets of decarbonization of the aerospace industry, we need to step up to different technologies, which is leading to breakthrough innovations ongoing on the sector. Making all the engineers working on some very interesting subjects that we can discuss later during the conversation today.
So talking about sustainability and fuels, I want to dive a little deeper there. Can you explain the role of sustainable aviation fuels, or SAFs, in the journey toward decarbonization? And then what challenges need to be overcome for widespread adoption here?
Yeah, this one is an important one because SAF is a must. If we want to achieve the targets from decarbonization of the aviation industry, we need more SAF. So today it's already in use, but from the top of my head, I would say SAF represents 0. something of the total fuel consumption in aviation industry, 0.1, 0.2, 0.5. Doesn't really matter. It's nothing. So today, SAF is already used. It's blended with normal kerosene, normal fuels to make some greener aspect and some economy and stuff like that. But if you think about it, with the level of production that we have today and the level that we should reach with a broader use, that's a scale up that is massive. So there is a lot of challenges in the scaling up the production. There is also different technology of SAF. There is the biofuel, if you will, that could be from woods and waste, methanization and stuff like that. Maybe the term is not that right in English from because I'm French, but and there is also the synthetic fuels, and there is a race with the two, and also uh, aerospace is not the only industry that want to use SAF. You know, if you think about it, there is the Volkswagen CEO recently said, "I will need synthetic fuel for my car because I cannot electrify everything, so I will need that." So there is a competition between the industry, but definitely for aerospace, SAF is truly a big deal. Today, I think the highest blend, if I'm right, it's roughly 10% of blending with normal kerosene and stuff like that. The goal is to reach, I think, by 2030 up to 30% or something like that, or by 2050. So there is a huge increase which needs a ramp up in production, a ramp up in supply chain, how to get the SAF to every single airport in the globe. You know, for the Western countries, that's easy because we converted some refineries to produce SAF for the synthetic ones. But what about the other countries on the planet? So there is a lot of challenges, technically speaking, to produce that, to scale up the production, and also to have the supply chain reaching every single airport on this planet.
Yeah, and there are a lot of entities involved when it comes to decarbonization. So, how is the regulatory landscape shaping the efforts of aerospace companies in reducing their carbon footprint?
This one is a difficult question. So the regulatory landscape, the first of all, as there is the commitment from the industry, the first regulatory landscape is that people have to reduce emission. So that's been the aerospace industry have to reduce emission. That's the commitment that was done after the Paris Agreement. So that's the first regulatory. The other regulatory, it's a tricky question because as soon as you change something in the aerospace, you need to validate. So there is some regulation to be changed or to be adapted with the new usage that you are using, either SAF or other technology that you are bringing need validation and regulations. And on the ground, if you bring SAF, does it mean that there is modification and about the regulatory for the supply chain and the delivery and all that? So there is a lot of discussion going on that on the industry, and everything is not solved yet. And we will speak, I think, later on about electrification. That's also bringing a lot of question about regulations, the electrification about aircraft. Because once again, safety is key in aerospace, and you cannot play with safety in aerospace. So it's a very important question. A lot of open-ended question right now, and a lot of question that need to be solved by 2030, 2050. So it's tomorrow.
Yeah, to be determined. I guess we'll leave it at that, right? So, let's talk about the bottom line for a moment. What economic impacts do you foresee as the industry shifts towards greener technologies and practices?
Once again, a great question that it will have some impact on the economy. If you think about it, SAF is today, there is debate as well, 2 to 4x more expensive in terms of production versus the standard fuel. So if you think about it, it's not the only cost in the aerospace industry, but ticket price should raise if you use more SAF because it's more expensive. Bringing new technology, it's quite expensive in terms of R&D efforts. Bringing new infrastructure on an airport, because if you think about electrification and all that, that means you will change a lot of things on the infrastructure of the airport. That's cost. So at the end of the day, we will see some evolution in terms of prices, in terms of cost, how much it's impossible to say right now, and I think it will depend. It will depend about how it's accelerating, how broad each technology will be implemented, how the regulations and the policies will drive the change as well, because the cost will be potentially higher with penalties that you could have from policies. So at the end of the day, we will have some impact. Who knows how much, when, and what? But we will have some impact on the economy for the end user, for people that are flying, but also for the companies, for the airports operators, for Airbus, Boeing, and all the big players. So it's part of the equation, and once again, still to be determined.
Yeah, and I mentioned before, a lot of different entities involved here. This is not something that single-handedly one group or organization can take care of. So how do collaborations between governments, private sector companies, and research institutions contribute to the overall advancement of decarbonization in aerospace?
It's highly dependent. When I'm speaking to my American colleagues, for instance, it's different in North America and in Europe. In Europe, there is a lot of investment from governments. For instance, in France, we had the 2030 plans from the government, helping company to develop the technology, achieving noble goal like decarbonization and stuff like that. So there was a lot of incentive for the industry financially, and also a lot of project launch in Europe, across Europe, to decarbonize the aerospace industry. That was part of some industry with some energy sectors, some the medical sectors and all that post-COVID, to relaunch the industry. So in Europe, we had a lot of incentive to make R&D projects and to make also partnership between university, partnership between different industry players. In the US, that's a bit different, and that's why also we see different trends. In Europe, we see SAF being one trend, but also electrification, hydrogen. In the US, it's mainly SAF because it's mainly driven by the private sectors, and all the other investments need to be financed. And without incentive, that's a lot of investments with a lot of uncertainty about is it feasible to do that. So the government, private, and also the universities and labs are collaborating at the global scales, but it's different from North America to Europe. I cannot speak about China. China is a bit a different animal, but it's a bit different from Europe to North America.
So we talked about the fact that this is not cheap to put a lot of these practices into play. So what are the biggest challenges aerospace companies face when trying to balance economic viability with environmental sustainability?
I heard some people on backstage, big people from big companies, and saying that it's a question of life or death for the aerospace industry. We have to decarbonize because we cannot. The world is going to the decarbonizations. If aerospace is not, why not? Automotive is making big step to electrifications, and we are asking a lot to the industry to decarbonization, and also to the people, actually us. So the industry is thinking they must decarbonize. So there is a trade-off economically, and as we spoke earlier, we will have some evolution on the price on the tickets, which is unfortunate for us because I love to travel, and I have to admit I love to travel with my family. Sometimes, for some people, and I have that, it's like if you want to see your relatives, sometimes you have to fly, because now the world is global, so people moved around and now they live in different countries. Or if in the US, if you live in Los Angeles or in Philadelphia, close to you, it's you have to fly, to drive from Philadelphia to Los Angeles, that's quite a drive. So at some points, we will have to modify a lot of things, and people will have to make some compromise. So there is a lot of challenges for the aerospace industry. That's why some companies like Airbus are investing a lot right now to be able to continue to deliver the aircraft to have people flying around in a sustainable way. Maybe less, maybe more. I don't know if we find a magic answer to that, and I don't think anybody can say that. But there is a lot of challenges. But in terms of viability, I heard people saying it's a question of life or death for the industry, and yeah, that it is what it is. Now we have to move on.
And speaking of moving on, let's move on to the next question. What role do you see electric and hybrid electric aircraft playing in the future of the aerospace industry?
Yeah, once again, this one is a lot of debate in the industry. Airbus is thinking that electric hybrid is one way, and it will depend from the short, mid, and long travel aircraft. what we call the single or twin aisle aircraft. So for the short one and the regional aircraft, electrifications or hybridations would be a way. That's seen as a way from an Airbus perspective. SAF is more prevalent for the twin aisle, for the long distance aircraft, for the transatlantic or something like that. So definitely we will have a mix. We will have definitely a mix between electrical aircraft. Today it's only for small aircraft. I think one company is flying for a two-people aircraft, which is not much. It's foreseen that for small distances, maybe we're going to have like 20 people aircraft very shortly in 10 to 15 years, depending of the safety validations and all that. But electrification, either full electrifications or hybridations, will play a role moving forward. Together with SAF, together potentially with hydrogen, if we are able to, I would say, unlock some technical challenges that we have right now.
And a follow up to that, can you discuss the potential of hydrogen fuel cells in reducing emissions and the practical challenges then associated with their implementation?
There is a lot of challenges, and hydrogen could be used in different ways. People are studying hydrogen to be used as liquefied hydrogens on the aircraft. There is a lot of question about it because it's dangerous. It's pressurized liquefied hydrogen, so it's kind of dangerous to fly with what some people will say a bomb on an aircraft. And you can say, okay, we can have hydrogen and to convert that in electrical to make the propulsion of the engines as well, like electrically so use the fuel cell to electrify the engines. So hydrogen is theoretically feasible. There is a lot of work going on, mainly in Europe right now with Airbus. Airbus has a program called Zero Emissions that they plan to start the validation. I thought that at the top of my head, I think it's 2035 that they want to bring to the validations. So it's once again tomorrow for the aerospace industry, a full hydrogen aircraft. There is different project going on in Europe on that, and it will come. In which form, as I said, would it be fully hydrogen aircraft, or would it be hydrogen to electrifications, or would it be burning hydrogens? Because you can only also use gas hydrogen and burn it into turbines as a fuel. So there is different ways that are studied and racing against each other right now, to be honest. And I don't think there is one magic solution, and potentially we will use different solutions moving forward. The best suited for the best use. As I said, there is short run flights, medium ones, and long ones. Potentially, they will use different solutions.
And what we're talking about here today, I mean, you talked about traveling with your family, and if you're a flyer, then this will directly have an impact on you, maybe if those ticket prices go up, but this really affects all of us. If you never leave the place where you were born and raised, and I want to talk a little bit about that. What impact do you anticipate decarbonization efforts in aerospace will have on the global supply chain?
It will have a lot. It will have a lot at different level. The global supply chain from the aerospace industry, because all these technological evolutions will impact the global supply chain. So not only Airbus and Boeing will adapt, all the supply chain should adapt. Because there is repercussions for the suppliers. Today, Technetics is very proud to solve a lot of issue on the current technology, and we are working on the future technology, but potentially it will change some of the way we operate, and it will impact us. It will impact the whole supply chain. The supply chain is not limited to the OEMs, the suppliers, and stuff like that. It's also the supply chain, as I said, for the SAF. How to bring SAF to the global supply chain and the global airport platforms, while maybe there is concentration of production of SAF everywhere. Hydrogen, if it's coming on board as well, how you bring the supply chain of hydrogen and how do you modify the infrastructure about the airports to be able to handle this modification about the supply chain. So there is a lot of questions and a lot of modifications that needs to happen in a very short time, because when the commitment is like by 2050 to achieve the commitment from the aerospace industry, it's truly tomorrow from an aerospace duration perspective. Because if you think about all the safety validation and all that, it's normally taking a while. So we need to act now to be ready by 2030 for the first step and 2050 for the second step. So the supply chain will evolve without any doubt.
You mentioned infrastructure. How are aerospace companies addressing the carbon emissions from ground operations and airport infrastructure?
This one is a big one because we spoke a lot about the technology aspect on the aircraft itself, but to achieve the decarbonizations, the the airline have a role as well because they can play a role on route optimizations, because if you take a longer route you will have more consumption, so more emissions. So there is a lot of things like that. The air traffic control is also one big topic that have an impact on the infrastructure on the airport and all that. The fleet turnover, it's also an infrastructure things, because there is a race right now to renew the fleet from each airlines right now, and that's why the backlog from Airbus and Boeing is so huge. If you want to buy an aircraft right now, I think with Airbus and Boeing, that's the same thing. You need to wait 12 years before you have your aircraft, if you're lucky enough to have the money to buy you an aircraft. But so there is a lot of modification, not only technically on the aircraft itself, but the way we operate the whole infrastructure, the whole, let's say, supply chains about the aerospace, how we move people around. So the taxiing, instead of they are studying, instead of having taxiing done by the turbines of the aircraft, to have like electrification on that. So we need to change the push-pull vehicle that is doing that to be electrical, but how to plug it in and to reload it, the battery of this electrification. So there is an impact on the infrastructure that people don't see today that is going on in terms of discussion. So this is a bigger question than just changing the turbines of an aircraft.
Yeah, and you talked about, needing to act fast because we need to have some of these changes in place yesterday, right? But let's talk about the future for a moment. What future trends do you predict will define the next decade of decarbonization in the aerospace industry?
This one is a tough one. I think that the trend is already ongoing. The trend is like there is a commitment to decarbonize, but I think that would be asked more and more. That's something we could see in Europe. I don't know if you see that in the US, but the young people, they ask for decarbonized stuff. They are more focused on the environment that my generation was, I think, back in the day. And there is different trends from the user perspective, from the industry perspective, and also there is trends from the government perspective. Some of the government, they already implemented policies with carbon taxes, with stuff like that. So there is different trends that are not technological. They could be political. People will be potentially elected by bringing new policies. So this is trends that we don't have to overestimate. I know, American perspective and European perspective are sometimes different. But if you think about it, not to speak about aerospace, but if you think about a country, it's China. Um, they have some trends that are forced by the government. I think 15 years ago they said we cannot sell anymore any motorcycles like the small ones, the mopeds that are with gas. They are all electrical for 15 years because the government set up the trend. It was not asked by the people, not asked by the industry. They set up the trends, and sometimes are the people that are setting the trends. So there is different trends that could come from different angles, but I think they will all converge to the decarbonization. That's the trend that is ongoing, and I don't think you can stop it right now.
How can policies and incentives from governments accelerate the industry's decarbonization efforts?
I think it's already accelerating. I mentioned that the plans in the French government, I think it was the same in Germany, and that was a European trend after COVID. Um, Governments across Europe invested into R&D to accelerate the development of that and to accelerate the decarbonization. As I touched base earlier on, policies could impact. If at some point in France, but I know in some countries it's already being discussed and or already implemented in some industries, carbon taxes policies. could accelerate it. If your price is going up drastically because you have a tax to pay on carbon tax, it will lead people to accelerate the decarbonization. Sorry, some words are difficult to say for French people in English, but definitely policies and incentive will accelerate that. That's not a question. That's just fact that is happening today, and that will continue to accelerate and continue to impact the industry much broader in the future. I'm sure about that.
I feel like we cannot end a conversation with anything technologically connected without bringing up artificial intelligence. And that's exactly what I'm going to do here. What role do you believe digital technologies such as AI and big data will play in achieving decarbonization goals in aerospace?
So as for everything, it's playing a major role, and I can name a few things. Uh, Big data, AI are accelerating the design work, the testing work, simulations and all that. So it's accelerating. So as I said, it's we need to do that for tomorrow. So we need to accelerate the design work and the validation work, and it will play a role on that. But as I mentioned on the infrastructure side, the route optimization and all these kind of things, like everything that the airlines are working on and all that, they will need some big data analysis and the help of the AI to be sure that they will choose the most optimum routes for their aircraft, and to achieve the goal that we have for decarbonization. So for sure, it will play a role. It's already playing a role, and the more we advance in the journey, the more we're gonna have stuff to validate. The more we're gonna overcome some of the first challenges. Some other challenges will come where AI and digitalizations and big data will play a role to be able to be fast enough and good enough and to respect all the policies and the rules from the industry.
Talking about decarbonization efforts and goals in the aerospace industry with our guest, Stéphane Guignard, who is Director of Strategy at Technetics. Stéphane, thank you for your time. Very interesting conversation. And as you said, it's exciting to see where things are going, and it will be very interesting to see where we are in the next 5 or 10 years, as you said. So thank you so much for your time. Thank you for being here today.
Yeah, thank you, Michelle, and happy to discuss with you when we know a bit more about this to be defined stuff in the future.
Yeah, podcast part two. And I want to thank you all for tuning in and listening to Getting Technetical, a podcast brought to you by Technetics. And of course, you can visit technetics.com for more information on this podcast. And be sure to subscribe to the podcast to get more engaging conversations like the one you heard today. I'm your host, Michelle Dawn Mooney. Thanks again for joining us. We hope to connect with you on another podcast soon.